All right, let's look at the homogeneous linear equations. All right, remember that the homogeneous means that the right-hand side is equal to 0. So you have equation which is given here. All right, then there's an interesting theorem about the homogeneous linear equation, which is this. All right, this is called the principle of superposition. All right, it says that if y1 and y2 are solutions of a homogeneous equation, so you have two solutions, then any linear combinations of those two solutions would be a solution too. Right? And also, here's a remark. Right? This theorem does not apply to non-homogeneous equations. So it's important to have 0 on the right-hand side. All right, so proof is actually pretty straightforward. Let's go through this. All right, here is the proof. All right, so since y1 and y2 are the solutions of a homogeneous equation, so y1 and y2 of course satisfy the original differential equations. So we have those two equations. All right, so let's look at the linear combination of those two. So I'm going to call that y. All right, then we take the derivative. So y prime would be c1 times c1 prime plus c2 times c2 prime. Of course, y double prime is going to be c1 y1 double prime plus c2 y2 double prime. All right. Then we have, let's try to see if this satisfies the equation. So I'm going to start with the left-hand side, which is the left-hand side of the differential equation. So I plug y double prime, y prime, and y in. So we get this equation. All right. Then what we're going to do here next would be, we're going to just collect terms. So let's see, I'm going to collect the terms with a C1 in it. So here's a C1, and there's a C1 here, right? And there's a C1 there, right? So what we're going to do is I'm going to put all the terms that has C1 in it, right? So C1, right? So you're going to have a Y1 double prime. All right, then it's going to be C1. Actually, we have to combine that with Px, right? P of x. So we're going to have plus P of x times Y1 prime and Q of x, Y1. So plus Q of x, Y1. All right. And everyone else seems to have C2 in it, so I'm going to plus C2 is pulled out. So we have Y2 double prime plus P of x, Y2 prime plus last one is a Q of x, Y2. All right? Since y1 and y2 satisfy the original differential equation, you can see that this guy right here, since y1 is a solution, this is going to be equal to the right-hand side 0. And since y2 is also a solution, so this is going to be actually equal to 0. Right? So I'm using these two guys right here. Right? So which means that the whole thing becomes actually 0. Which is the right-hand side of the differential equation. Right? So this verifies that any linear combination C1 y1 plus C2 y2 is also the solution of the given homogeneous linear equation. Right? That's it. I hope that this was clear.